So a farmer will earn 125,000 once it rains, in which case the profit is only 150,000, and there's a 15% chance of rain before harvest. So A here asks, what is the expected profit of this crop? Well, so again, let's make a little table here, X, P of X table. And in this case, instead of the X being the winnings, the X is going to be the profit. So this is fairly straightforward because two profits possible here. We've got 125,000 profit, or we've got a 50,000 profit possible. All right. All we then need to supply here are the probabilities of those. Well, there's a 15% chance of rain. How does that tie in? Well, a farmer earns 125,000 unless it rains. So if it rains, you get the 50,000. So there's a 15% chance of rain. So isn't that the percentage for the 50,000? So on the rain, you get the 50,000. So 15% chance of rain. So the probability that we get the 50,000 is 15% chance, or 0.15. So what does that make the probability that we get the 125,000?
85.
So that'd be the 85, or 0.85. Everybody with us there? So I want to calculate the expected profit. So again, that's just like we were doing here. Just multiply each X times P of X. So I'll do the 125,000 times 0.85. And then the 50,000 times 0.15. See what that gives you. So that's a pretty good little number there. Get my fingers out of the way here. 125,000 times 0.85 plus, so that's 106,250, and then 150 times 50,000 times 0.15, it's 130. Whoops. That's not right. 50,000 times 0.15. See, that's 7,500. So yeah, that gives me, what does that give me? 113,250. I did my calculations there
We
correctly?
did 750. 113.
750, yeah. Just check. All right. All right, now, so that's pretty straightforward. But I have a couple other scenarios here. Let's talk about B. If an insurance company offers him a $60,000 policy, all right? So we've got an insurance policy being offered, and it's $60,000 with $15,000 premium. Okay, of course, what that means is you know, if for rain, against rain. So this is hedging our bets, I guess you might say, that it's going to rain. So in other words, you get the insurance pays the $60,000 if it rains. However, no matter what, you're paying $15,000. The farmer pays the $15,000 premium. Okay. So let's see how that factors. What if he takes this if he takes this insurance policy? What is the expected profit then? So that changes our profits up a little bit. Let's think about that. So we still got the 125,000 and the 50,000. Those numbers are still valid here. However, let's think about again the no rain here. First of all, So if it doesn't rain, the farmer gets the 125,000, but he has paid, since he took the policy, he has paid the 15,000 premium. So he hasn't made the full 125 because he has paid the 15,000. So isn't this number here 125 minus the 15,000? So that number is 110,000. So the profit goes down there in that case because we paid the 15,000 premium, right? And that's the probability that it's no rain is still 85%. So if it rains, okay, if it rains, well, the profit's only from the crop is only 50,000, and we paid the $15,000 premium. But what kind of makes this interesting is he will get the $60,000 insurance from the insurance, right? Because the $60,000 is for rain. And so that profit now becomes, add and subtract those up, is that 95,000? 95,000? So that bumps this number up, which is why maybe this person would do this. And that's, again, chance that it rains is 15%. Does everybody see where we got those numbers? We had to subtract the 15,000 here, had to subtract it here too, but we got the 60,000 from the insurance. So let's see if that makes our expected profit now any better. So now we take the 110,000 times 0.85 plus the 95,000 times 0.15. Does that make the number come up any from this? 110,000 times 0.85 plus 95,000 times 0.15. Nope. So even though we get a little more in that second scenario there, the expected profit is a little lower than what it was originally anyway. So probably wouldn't be a good bet to take that policy. So it's just kind of an idea of how this might be utilized in this simple scenario anyway. But any questions on that? Let me do then the C part there. All right, so this was the expected profit from the perspective of the farmer. So C asks about, well, what about the insurance people here? So what is the insurance company's expected profit? Well, that's going to change our table up as well, because the insurance company is not getting any part of the 125 and the 50,000. Let's just think about what profit does the insurance company potentially make here. So this is the insurance company's profits possible. Well, of course, they're getting the $15,000 from the farmer. So they could make $15,000. However, they could pay out $60,000. But that's only if it rains, right? So if there's no rain, in this scenario, then they're getting the $15,000. So they get a profit of $15,000. And that's if it's no rain and the 15%, still 15% chance of rain, so no rain is still 85%. But if it rains, what's the profit then for the company? Yeah, they get the 15,000, but they have to pay out the 60,000. So actually they lose on that case there, don't they? 15,000 minus 60,000, what was that, negative 45,000? Yes? Does everybody see that? And that's a 15% chance, because that's a chance, 15% chance it rains. And so the expected profit for the company, well, you do your 15,000 times 0.85 plus the negative 45,000 times 0.15. And I think that still comes out, even though one of them's negative, that still comes out, because this is 12,750. And then that's negative, of course, for 6,750. So yeah, that's still a 6,000 expected profit there. So probably wouldn't be a good bet for the farmer, but you can see why the insurance people would, because they're going to profit. They're going to expect to profit anyway from selling these policies. So anyway, all right.